Aloha class, here we go. Judgment week number 3, Sanban. Remember, same as always, okay? See if in 22 and a half minutes you can print this out, put all your solutions down, take a picture of it, find a way to send it to me. After you're done doing all that, unpause this video and let's see how you did, okay? So make sure you're doing that. 22 and a half minutes. Try to get it for under 20 minutes just in case something were to go wrong, okay? Let's do it. All right, consider the closed curve in the xy plane given by 2y to the third, blah, 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 blah. Show that dy dx is equal to, okay, so really what we're going to do is we're going to find the derivative. It's got some y's in it, so we're going to find the derivative implicitly. So here we go. We're going to go 6y squared dy dx, right, because it had a y in it, minus 6 dy dx plus 6x minus 18 is equal to 0. And then remember what we do in these situations is we get all the dy dx's on one side, and we get rid of everything else, and we also factor. So I'm going to kind of do two things at once. Hopefully I don't lose you. If I do, then I will see you on Google Meets. Okay, there we go. And then all we have to do now is divide that out, and we're really donezo, remember. Okay, and then remember, you're really not going to need a calculator on any of these problems, which means you're just going to have to show your work. But if we take a 6 out of everything there, I get a negative x plus a 3 over y squared minus ichi, which is exactly that. Booyah, that'd probably be worth, I would say, about a couple of points on your AP exam, okay? All right, let's go to part B. Write any, and make sure you guys, it says right here what we're expecting you to see, okay? So make sure you just, label correctly when you're doing your practice exams here with me, okay? And do the same thing when you take the real one on May 12th. All right, write an equation for the line tangent to the curve at 2, 3. Use this line to approximate. So I know a lot of you guys were asking this the other day. This is linearization, right? And we're not going to use 1.9. Instead, we're going to use 2, okay, 2, 3, which means we got a little y minus y1 equals m times x minus x1, okay? And that's going to be a pretty good approximation because 2 is really close to 1.9ers. Right? And then all we have to do now is to find the slope at 2, 3, which means we're going to use our derivative, and we're going to, then remember, that would be correct notation. It means we're going to use the derivative, and we're going to plug in a 2 and a 3, which would give me what, a 3 minus a 2, and then a 9 minus a 1, which gives me 1/8. Okay? And then I just have to plug this in, and I'm going to make it fancy. Okay? And I probably should say let y equal L of x, right? That's what we're doing here, which would be 1/8. And remember, you don't want to distribute because once again, you're going to have to show your work here. And we're going to use this linearization for 1.9. Okay, and the reason why we don't want to distribute is because now, look, the math is very doable. You get negative 0.1, which is 1/10. And you should be able to do that stuff, right? And so what do we get? We get 3 minus 1 over 80, which would be 2 and 79 over 80. Booyah, dunzo! And you know what? That probably would be worth a couple of points. And then now you guys are saying, well, Mr. Tanaka, that's not even part B. That is C. I think I got a little bit excited. So we still have to do part B, okay? But that one there would be probably worth a couple of points. And then we have part B. I apologize. Let's go back. We'll just do it right up here because that's nice and easy, Japanesey. Right, our curve is going to have a horizontal tangent whenever the derivative is equal to 0. And the derivative would be equal to 0 whenever the top was equal to 0. So let's go ahead and set the numerator of my derivative equal to 0, right? Because in essence, whenever the derivative is equal to 0, I get a horizontal tangent. And we have to make sure we're very careful and we are aware that we do not get a 0 over 0 situation, correct? Because that would be a vertical tangent, okay? So how could I make sure I don't have a 0 over 0 scenario? Well, you could plug a 3 in there and see what y would be, okay? And that would maybe be a good check that you should do, but I think this would be sufficient, so just be worth a point. in itself, okay? And the reason why I say use your 3, if you plugged a 3 in there and you ended up getting a 1 for the y, right? A 1 for the y would mean I would get a 0 over 0 situation, okay? All right, let's go to part D, because we just did C before that. I apologize. It says determine the concavity of the curve at the point 2, 3. Concavity would mean second derivative. So we're going to go ahead and we're going to find the second derivative, okay? And second derivative would be a little quotient rule. Sure, that guy's going to come up, which would be the low times the derivative of the high minus the high times the derivative of the low, which would be 2y dy dx. Okay? And then that's all over. Okay, and then remember, correct notation would be, okay, there's my second derivative, and I'm going to plug in a 2 for my x and a 3 for my y. So let's go ahead and do that, and that would give me an 8, right, minus, would that be 3 minus 2, it should be ichi. And then what would that be? 2 times 3, which would be 6. Probably should show a little bit more work. dy dx. dy dx was 1/8, and we found that right in the step before, which was the slope. Okay, all over low, 8 squared, which would be 65. And if I do all that correctly, I get -8 minus 6 over 8. And you know what? That would be enough work to say that would be less than 0. And since it's less than 0, we know that it is concave downers. Okay, so it'd be concave down. Get a couple points for that bad boy. Splingy, splingy. We are dominating this one. Now we have E. Is it possible for the curve to have a vertical tangent at the point where it crosses the y-axis? Well, where it crosses the y-axis would be when x is equal to 0. Right, class? Where it crosses that, or I know my vertical tangents have to occur when the bottom is equal to 0, which would be at plus or minus 1. Okay, and so it's asking, okay, and then it also would have to be when x is equal to 0. So let's go ahead and find out where the vertical tangents are, which is this, and let's find out what those x coordinates would be. Okay, and how do I find out what the x coordinates would be? Well, let's go ahead with y equals +1, and let's plug that guy in, and we would get what we would get. We get 2 minus 6 plus 3x squared minus 18x equals 12. And that gives me a 3x squared minus 18x. That's a -4. You bring -16 equals 0. And you would have to solve that, or notice that, hey, if x is 0, it's not a solution. So x equals 0 is not a solution. So that means there cannot be a vertical tangent in that place. Okay, now let's check y equals -1. Okay, let's put a -1 in there, and I get a -2. I get a +6 this time. Plus 3x squared minus 18x. I wonder if this one works out. Let's check it out. We get a 3x squared minus an 18x. That's a 4, and then you bring that and be -8 equals 0. Right, now let's go ahead and check that one out. Let's plug in a 0. Does that guy, if I plug an x equals 0 in there and 0, I get -8 equals 0. That doesn't check out. So there we go. That was enough to show that there cannot be any vertical tangents when where it crosses the y-axis. And I wouldn't spend time doing the quadratic formula on that guy or factoring that guy. We would just have to know the only time it could cross the x-axis, a vertical tangent, would be if x was 0. And that'd be enough to show that, hey, that works out. Booyah. I don't know about you, but that was not too bad. That would have been a total of 10 points. So let's see how you guys did. I have the breakdown of points, boom, right there. Okay, 2 for part A, 1 for part B, 2 for part C, 2 for D, and 3 for part E. What's that? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Once again, 7 and 8 means you should be feeling pretty darn good about yourself. Okay, 5, we should be doing a lot more study and making a lot more of these videos. The videos are money. They're beautiful. They're so fun to watch, and there's so much great cooperative learning going on. Keep making those videos. Keep taking Judgment Week seriously. We've got 2 more to go. All right? Aloha!